Are you evaluating a modern application security platform that balances speed, accuracy, and developer experience? In this review, we dive into Semgrep, a developer-first security tool that combines static application security testing, software composition analysis, and secrets detection into a unified workflow. We will cover how it works, how it integrates with development pipelines, how it compares to legacy SAST, what languages and frameworks it supports, and whether or not it uses AI. Let's start with the problem Semgrep was created to solve. Traditional static analysis tools often require extensive configuration, run slowly, and generate noisy findings that interrupt developer workflows. This creates tension between engineering velocity and security requirements. Developers push back because slow or opaque scans block pull requests and flood them with false positives. Security teams struggle to enforce policies without becoming a bottleneck. Semgrep aims to break this deadlock by being fast, transparent, and customizable. At its core, Semgrep uses pattern-based static analysis guided by semantic understanding. The engine parses source code into abstract syntax trees and matches code structures against rules written in a readable syntax. Instead of relying on opaque models, you get explicit patterns that say, match this function call with these argument shapes in this context. This approach yields precise results for common vulnerability classes and framework-specific misuses, while giving you the power to author or tune rules to match your codebase. Semgrep consolidates three pillars of AppSec. First, static application security testing finds code-level issues such as injection risks, insecure deserialization, cryptographic misuse, risky file operations, and insecure defaults. Second, software composition analysis inventories open-source dependencies, flags known vulnerabilities, and can help enforce version and license policies. Third, secrets detection identifies hard-coded credentials, tokens, and keys in code and configuration, reducing the risk of account takeover or unauthorized access. By bringing these together, teams reduce tool sprawl and centralize triage. A major advantage is the Semgrep Registry, a large collection of community and vendor-maintained rules. You can start with curated rule packs for common frameworks and languages, then add or modify rules for your own standards, APIs, or domain-specific checks. Rules carry metadata such as CWE and OWASP top 10 mappings, severity levels, and remediation guidance. This makes reporting easier and ensures findings align with compliance frameworks and audit requirements. Performance is a key differentiator. Semgrep is designed to run quickly in pull requests, so developers get feedback within seconds or a few minutes. Rapid feedback enables shift-left security without delaying merges. When findings do occur, engineers can usually see exactly why a pattern matched, which makes remediation faster than with black box tools. Teams can set thresholds to fail builds on high-severity findings while allowing lower-severity issues to pass with warnings. Accuracy and noise reduction come from precise patterns and semantic analysis. Because rules target specific code shapes and contexts, false positives are generally lower than in legacy SAST tools that rely on broad heuristics. You can refine rules to eliminate noisy matches in your environment. Baselines help you prevent reopening known issues after a large initial rollout. Suppression workflows let you acknowledge risk with documented justifications when appropriate. Integration is straightforward. Semgrep fits neatly into GitHub Actions, GitLab CI, Jenkins, Bitbucket pipelines, and Azure DevOps. Many teams run Semgrep as a pre-commit hook for immediate local feedback, then in PR checks for gating, and again in nightly or weekly full scans for comprehensive coverage. Results can be exported as serif to integrate with security dashboards and code hosting platforms. Notifications can flow into Slack, Microsoft Teams, or ticketing systems such as Jira to streamline remediation. Language and ecosystem coverage is broad. Semgrep supports many popular languages including Python, JavaScript, TypeScript, Go, Java, Ruby, PHP, and C and C++. It also checks infrastructure as code and configuration formats such as Terraform, Kubernetes manifests, Docker files, YAML, and JSON. This breadth lets platform and security teams apply consistent policy across microservices, backends, frontends, and DevOps configurations. Now to the AI question. Does Semgrep use AI? The core scanning engine is deterministic and rule-driven, which provides predictability, auditability, and control. However, Semgrep also offers optional AI-assisted capabilities designed to speed up triage and remediation. These features can explain findings in plain language, offer context-aware suggestions, and help propose fixes. Crucially, the findings themselves come from clear, inspectable rules, not from an opaque model. This hybrid approach gives you the best of both worlds: reliable detection and faster developer workflows. How does Semgrep compare with other tools? You might evaluate it against GitHub CodeQL, SonarQube, SneakCode, Checkmarx, Veracode, or Fortify. Semgrep's standout qualities are developer experience, customizable rules, fast feedback, and transparent detections. Where legacy tools can be slow and noisy, Semgrep aims for actionable signal on each commit. CodeQL is powerful for deep data flow analysis and custom queries, but can be slower to tune at scale. SonarQube provides code quality metrics alongside security findings. SaaS-first platforms like Sneak often excel in dependency visibility and developer ergonomics. Your choice depends on how much you value rule transparency, speed in PRs, and policy as code. Common implementation questions come up in nearly every evaluation. Can you run Semgrep entirely in your environment? Yes, the CLI can run on developer machines and in self-managed CI, suitable for regulated settings. Can it scan large monorepos? Yes, it is commonly deployed in monorepos with selective directory scopes and incremental scans to keep runtimes short. How do you reduce developer friction? Start with a read-only phase, apply a baseline to avoid failing builds on historical issues, tune rules to your frameworks, and enable autofix or explanation features to aid developers. How do you measure value? Track mean time to remediate, percentage of PRs blocked by true critical issues, and trending of high-severity findings over time. Align rules with your top incident root causes and the OWASP top 10 to ensure impact on actual risk. Security leaders often ask about governance. Semgrep enables policy as code, letting you version rules in Git, require reviews for changes, and roll out updates gradually. You can map rules to internal standards and regulatory obligations, tag them by team or service, and scope checks to particular directories or repositories. This governance model is easier to audit than black box tools and scales with your software delivery lifecycle. What about secrets and supply chain? Secrets detection can prevent the most painful class of incidents, leaked credentials. By running pre-commit and NCI, teams catch tokens before they hit a shared branch. For open source risk, SCA highlights vulnerable transitive dependencies and suggests upgrades. You can generate or ingest SBOMs and close the loop with ticketing and automated PRs when patches are available. Who benefits most from Semgrep? Developer-centric organizations that want fast, explainable security feedback in pull requests. Teams that need to encode internal best practices as enforceable rules. Companies aiming to consolidate tools while improving signal to noise. If you value speed, transparency, and control over your security checks, Semgrep is a strong candidate. In summary, Semgrep provides a pragmatic, developer-first approach to application security. It unifies SAST, SCA, and secrets detection. It runs quickly, integrates cleanly with CI and developer workflows, and offers transparent rules that you can adapt to your environment. Optional AI assistance accelerates triage and remediation without turning detection into a black box. If you are looking to shift left without slowing down, Semgrep deserves a spot at the top of your shortlist.